Hi guys, let's take a look at this question. Charles' law describes the relationship between volume and temperature of an enclosed mass of gas at constant pressure. The volume of a gas at different temperatures at constant pressure are given here below. 4.1.1. Explain Charles' law in terms of kinetic molecular theory of gases. Okay, so when the temperature of a gas increase, right, I'm just going to write it like in abbreviated terms here. When the temperature of a gas increases, the average speed of the particles also increase. Right. The molecules collide with the walls of the container more often with greater impact, right? And then these collisions will push back the walls so that the gas occupies a greater volume than it did at the start. So what am I saying essentially? That's a very drawn out thing, but I'm saying that when the temperature of the gas increases, the average speed increases. So the number of collisions increases and the volume that the gas occupies also increases. 4.1.2. Or you could have also said everything decreases. When that decreases, that decreases, that decreases, everything. So they are proportional. Draw a graph of volume versus temperature at constant pressure on the attached graph sheet. So you're literally just going to draw all these coordinates into a graph. So you'll have your temperature, degrees Celsius. You'll have your volume, centimeters cubed, and you'll have all your points here. So then you're just going to plot the graph, right? So it's going to be 0 and 114, so somewhere here. 25 and 124, somewhere right there. 50 all the way up to 134, so somewhere there. 75 to 145, and then 100 to 155, something like that. And you'll have just a straight line, so then you just connect your line. Okay, then they want us to extrapolate this graph and state at what temperature the graph intersects with the x-axis. Just going to extrapolate my graph, and then I'm going to bring down all the way down here. What would be that point there? That point we would call the absolute zero, right? And what is at the absolute zero? Negative 273 degrees. And what is significant about this temperature? The absolute zero. So the absolute zero, which is the coldest possible temperature at which the particles will have no kinetic energy. 4.1.5. Calculate the volume that the gas will occupy at 120 Celsius or degrees Celsius at constant pressure. So I'm going to use this formula. Volume over temperature is equal to volume over temperature, right? They've given us the volume of the gas, 155. The temperature is 100. So we work in Kelvin, right? So we got to add 273,15 to that 100 to get Kelvin. So we're just going to add that. We're going to leave the decimals and just say 373. And that's going to give us 120. So 120 plus 273 is going to give us 393. And I get my volume to be 163,331 centimeters cubed. Then they ask us to, now the experiment is concluded, right? And they want us to sketch the graph that will be obtained at a lower pressure, okay? So a lower pressure has a steeper gradient. So all we do is we just draw a line that is a bit higher than this line, like that. And that is it. And we will label it P. Then the last question, 4.2. An unknown gas with mass 0.77 grams occupies a volume of 0.32 decimeters cubed at a temperature of 27 degrees Celsius at a pressure of 96. Assume that the gas behaves as an ideal gas. Calculate the molar mass of the gas. Okay, so I have my pressure, I have my volume, I need my number of moles, I have this constant, and they've given me the temperature, right? It's going to be 96 times 10 to the power of 3 because it's like that. And then I'm going to have Also 0.32 times 10 to the power of -3 because they give me decimeters. I need my moles. R is a constant, which is 8.31, and they've given my temperature as 27 degrees Celsius. So I'm going to add 273 to that, and I'll get 300 because I need it in Kelvin. Then I do my math magic, and I get my moles or number of moles to be 0.012 moles. But I need my molar mass, right? So I use my normal formula to get molar mass. I can now jot in my number of moles. My mass has been given as 0.77 grams, and I can easily do my math magic and I get 64.17 grams per mole. And that is it, guys. See ya.